In this problem, we are going to find all the values of t for which g prime of t, or the derivative, actually equals 0. So we're going to start by finding the derivative. So we will use the power rule, g prime of t. When we bring down this 3, we're going to have 3 times 3, or 9 t squared. And the same thing here, when we bring down the 2, we'll have 2 times 2, or 4, times t to the first. 2 minus 1 is 1. Now we want to find, where does the derivative equal 0? Right, so we're going to actually set this derivative equal to 0 and then find the values of t which make that true. Now if a derivative equals 0, just imagine a function. Maybe this cubic looks something like this. It may or may not. But we're finding all the values where the tangent line has a slope of 0. That's what that means, where the derivative equals 0. So we're finding the places where it's horizontal or flat. There may be one place, 2 places, or maybe no place. Now to solve this equation, this is a quadratic equation. Luckily we actually don't have to use the quadratic formula because we can just factor t out from both terms. Easily factorable. We can't take anything out of the 9 and the 4, but that's okay. We take the t out, then we can set each factor equal to 0, so that gives us t equals 0 and 9t minus 4 equals 0. So one of the solutions is already solved for us, t is 0. This one we have to solve, so 9t equals 4, or t equals 4/9. So those are the two t values at which the derivative equals 0, where this has a horizontal tangent line. Now if you graph this function, you should see that it looks flat, roughly at 0, and then this is pretty close to about a half. So if you're just eyeballing it on the graph, somewhere between 0 and 1, close to a half, it should be horizontal like that.